Now, in the previous video, I actually talked about what you're looking at here, which is what we're going to achieve in the code in this current video. But I forgot to mention something. The reason why we're doing it this way is not just because we want to have an area where the ship, this ship or the Rect moves and it can detect whether it hits an area or not. But maybe we don't want it to be the entire area. Maybe we want a Rect that if it hits it here, if it intersects with something down here, then it'll do something like a wall or something here or a door here, and it'll do different things. So that's the reason why we're setting it up. And it's not that our game actually has those options in there, but we want to be able to prepare for our game to be we want to be able to prepare for our game to expand or to scale beyond what we actually have right now. So right now we're saying north, east, south, and west. Those will be doors, and anywhere on the north or east or south or west wall, it will go through. Now, we could have programmed it to say, okay, what's the dimensions of our canvas, and if it hits this top area, it's going to go north. If it hits this right area, it's going to go east, and so on and so forth. But that we'll be programming all of that simply to exit this canvas. We're killing two birds with one stone by saying, okay, we will create these areas that if it goes over it, it goes north, east, south, or west. But we also can maintain that code and use that code or that technology for other things in our game, like walls, characters, enemies, pylons, whatever it might be. So that's why we're taking this approach. All right, so let's get started. If you look at the previous video, if you want to start from this project file, just go look at the previous video, or don't even look at it. Go to the previous video and download that link that I have there, and it'll give you the project file that we're working on right now. So what we want to do is go ahead and start organizing this. And we also know, we already should know by now, that if we were to run this, we have a character that can move left, right, up, and down, respectively, depending on the arrow keys that you use. And we also are pulling in our information from our JSON file that we create. We initially create the classes and we serialize them into a JSON file, and then we deserialize them to use them into our game. And the only thing that we have here that's different than the previous video is the fact that we iterate through the caves, and we go ahead and no, this is actually the same from the previous video. We go ahead and put the cave title there, and this is what we're getting when we first start the application. This is the information we're getting when you see that inside of the label itself. So when I run this, I'll see this label up here with all that information. That's after it's been written to a file and then read from that file. That way I know my JSON file is working. I'm obviously going to take that out later when the final project is done. All right, so down here I have my game loop, and here is where I'm detecting whether I go left, right, up, or down. If you go a little bit further, you'll see right here, and I have this little to-do thing here, says remove on final, but I think I want to remove this now because this right here is related to the buttons click. If I were to deselect this, the buttons would work, but I really want to get rid of the whole idea of having these buttons here. So I'm gonna go ahead and be courageous and go ahead and delete that. Hit F5. Now, since I don't have those buttons there, I want to remove these buttons from here. So I'm removing any instance of these actual buttons. Now, in this project file, I already have some images without anything in there here on the stage. For the sake of us understanding what we're doing, it's probably better if we remove those images. I'll just remove one image, and then I'll show you what we have to do to get these images to work here. So I just remove the west image, and the other stuff we'll keep there. Now here is my label, and I want to go ahead and shrink that because I don't want that to be too much in a way, and this guy remains the same. All right, so now that we have this stage here all set up, we can now go ahead and start adding the elements we need in order to achieve our collision detection easily. So I'm going to go up here and I'm going to instantiate some Rects. And I already explained in the previous video what Rects are. So here I'm going to go ahead and type private Rect, and I'm going to call each cave, like the north cave, south cave, west cave, I'm going to create an invisible rectangle. Like the north cave is going to be this image here. It's going to be the same size as this image here. And each cave or each exit is going to have the same size as these images here. That's the main reason why I have those images there, just because I want to be able to draw out the size of the cave and then give that to the rect. That's why they're there. All right, so here I'm going to proclaim that I have rect cave north, and I'm going to dim that as a rect. And I'm going to pause the video and type out the rest. All right, so as you can see here, oops, typed that out twice. All right, as you can see here, I have this rect here. That's the north cave, south cave, west cave, and east cave. Now what I want to be able to do is instantiate those. But I want to be able to instantiate those after I create the caves, but before I go into the my loop. So that's going to be down here. So here's my game loop. So I want to do it somewhere in between here. So I'm going to actually put it right before I do this loop here. All right, so here I'm going to go ahead and instantiate my rects. So I'm going to put rect cave north, east, north. And that's going to equal it's going to equal my east cave dimension. So here is my here is my east cave here. And I want the dimensions to that east cave. So the way I do that is I'm going to go ahead and call upon this new rect, say a new rect, and then I'm going to give it the cave's location. And the way we do that in WPF is that we have to use the canvas itself to get the top and the left of objects. We can't just say the image dot top, because it won't really give us the proper dimensions. It'll give us the dimensions of the object itself from the origin of the object. So it won't be coming from the top left. So that's why we have to say the canvas itself will grab the location of the object. So when we go here, I'm going to call upon the canvas class. And inside the canvas class, there is something called get left, get right, get top. And we want the get left. And we want the get left of the ship. Oh, I'm sorry, the north cave. So this is north, right? So I'm going to say north cave. Now, after I do that, after I say, okay, I want the north cave, now I have to say what is the rect is going to take. Let me see right here. A rect is going to take the X, the Y, which is my left, and my top, and it's going to take the width and the height. So my top is going to be the next one that I need. So I'm going to say canvas dot get top. And this is my Y, right? And which top do I want? I want the north cave top. And then I'm going to say the width and the height of the north cave. Now I can take it directly. I don't really need the canvas to do this for me. The north cave dot width and the north cave dot height. Oops. There we go. So now I have the dimensions from the north cave, from the image here. This image here I called, if you look over here in my properties, the image is called North Cave, and this image over here is called East Cave, and so on and so forth. They're named properly, right? So I'm going to do that same thing for all the caves. So I'm going to pause this for a second and go ahead and do that. All right, so right now we have everything settled. We have the north, east, south, and west. And if you notice the west, it looks like there's an error there. There is an error there because remember, I deleted the west on purpose so I can show you how to put that on there. So I'm going to go here and I'm going to go to my tools. Let's see, right here. And I'm going to select an image right there. And I'm going to go ahead and drag that image out. And I'm going to balance this out, something like this. Okay, so this will be my West Cave. And I'm going to go ahead and name this West Cave. So I'm going to say West Cave. There we go. Now I should not see any errors back here. There we go. Now there's a problem with the left cave that you won't be able to see initially. Is that the left cave, when I drag the left cave out, you'll notice that down here it just has a top, right? So this can drive you nuts. You will not be able to get a proper coordinate from this left cave or this left image because of this. And so what we want to do, we want to explicitly set the top and the left. So right now I have a top, right? So even though I have a top, I'm going to go ahead and type in canvas.left, not bottom left. And I'm going to put that as nothing or 0. So you see it's still there, but I do have a value here. Whereas if you don't have a value there, you would think that it's already set, but that's not true. It will cause a lot of issues with the coordinate system, and it'll throw some numbers out there. Sometimes it'll come as NaN, N-A-N, and that's the whole reason, because it doesn't realize that it needed to put this here. So that's why we explicitly put it there. I'm not going to demonstrate it. Take my word for it. And by the way, all you need to do is remove this and then try it, and you'll see that the program will look like it's working, but you won't be getting the proper coordinates. All right, so let's move on from here. When we go back here, you'll notice right now I'm getting all of my information here, and I can run this, and you'll see that I'm not really getting any errors. You can see I'm not getting any errors. All my information is still there. There's no errors. Everything is still working. And I can go ahead and print this information out. So if I were to say console.write, and I'll do a right line. And I will take, let's say like this Rect. And here's the cool part about the Rect. We don't have to worry about going into the object and getting its margin because it has an X value, which is great, which was that Y. Remember that X value we set here? And so we have that X value. So I'm going to go ahead and print that out there and see what that X value is. When I run this, the X value is 0 because here I have it at the very top of my canvas. So when I go here and I look here and I see my left, which is the X value, you'll see that it's 0. Okay. And now when I go to this very same one and I'll use the Y, the value I should see is this 25. So I'm going to run that. And there it is. The value right there is 25. So my Rect has the same coordinate system and size as this image here. Okay. So there's two things here. There's something in code and actually something here. And why did I use images? The reason why I used images is the same reason why I used images here. Although I don't have an image there, I might put a brick here. I might put a door here. I might put some rocks there, you know, or enemy, whatever it might be. This is why I'm using images right now, because I know I'm probably going to be filling those images with something. And I want to do all my coding with images because I'll be using those as sprites. All right, so let's look at the code now. Right now we have some stuff happening over and over again. So that tells us that we probably should refactor this and make this more efficient. So I'm going to create a function that does this for me. And first, without even having the function, I'm going to go ahead and type the function out. So I'm going to say this cave right here will equal something called image to rect. Image to rect. And I don't have to make that I capitalized because this is I'm going to make this private. This is only for this class right here. And so I'm going to put the north cave in there. And after I do that, I'm going to hit Control, period, and then I'm going to hit Enter. Control, period. Okay, let me do this again for you. Control, period, basically is like me putting my mouse over here, going to this little light bulb here, and then choosing Generate the method that I just typed out here. And right below the current method, you'll have that method written out for you. So that's kind of a little shortcut key that makes your coding a lot faster. So now that I have this here, basically all I want to be able to do is change this. Instead of saying cave, I want to call this a sprite as an image. And now I want to be able to take my rect and I want to be able to return that. So I'm going to put return a new rect. And instead of, cave, I want to put sprite. That way I don't have to keep redoing this over and over again. I would have done this initially, but I think it's important that you see me do it the long way first and then see how I can make this actually more efficient. So now all I need to do is change all of these. So I need to get rid of this. Change all of these to using this right here. Oh, this is my east cave. I'll just redo this part right here. All right, so with that there, I still should see this return when I do this part right here. Everything should be exactly the same. Should not have any issues. And there we have it. It's printed out 25 exactly like what we expected, except our code is much cleaner and readable. Okay, so the next step I need to do is go ahead and add myself a rect for the ship. Right now I need a rectangle around my ship image. So I'm going to make one called rect ship. And that's going to equal it's going to be this alien. And I do all that first because I'm just going to let Visual Studio write this out for me. Go here, here, and I'm going to create a field. And just by context, it knows that this is a rect. So when it wrote it up here, it proclaimed it, declared it as a rect. Perfect. All right, so now I have my rect ship. So everything has a rectangle around it. Now we need to be able to use that. So I'm going to go down here to where I'm moving my character right here. And as you can see here, it says collision check here. So this is where I'm going to go ahead and start typing my collision detection. And the collision detection, I'm going to put inside of a procedure called collision test walls, because I might have all kinds of collision detections. It's not that it's a massive, a lot of code. There's no code because that's why we use the recs. It's just that I want it to be more readable inside of a function that will return things for me. So basically, I'm going to do something like this. If I want to be a collision test for the walls, and it will take, let's say, like the wrecked ship. It's always going to take the wrecked ship. And say like the Rect cave. And let's try the north cave first. Then do something. Okay. Now, this hasn't been written, and I wrote all that out so I can understand the context of what I'm trying to write. Then I can go ahead and generate this right here. And yeah, because I have a return value on that, it knew that it needed to be a function. So as you can see here, it returns that Boolean. It's taking the ship as the Rect, except I want to change this to, I'm going to change the ship to object A. And I want to change this to wall, because this is specific for the walls. And if I had something else, I can use it for that. Also make a different function for that. For right now, I'm just using walls, and what I want to return is object A. It's a Rect. And I'm going to use something called intersect with. Intersect with. And I want to check to see if it intersects with the wall B. That means the wall object. And that's all we need. Now it's going to return to me whether it has intersect with the wall or not. And that's why this works here. So if it does intersect with the wall, I am going to go ahead and print something out. Now, I'm going to be printing a lot of things out. So really what I want to be able to do is go ahead and create myself some sort of print function, since I don't want to keep on writing console write line. And so I'm going to say print print C for print to console. And put input. Okay. And now I can go ahead, write this for the last time. And the input. All right, so now I just have to go print C. Print C here. And I'm going to put inside of the print C. Hit. So now we haven't, the only issue we have now is we need, for every time we move the ship or move the Rect, the ship moves with it, or the Rect is moving with the ship, one or the two. Right now we have the ship, we set the Rect, right? So here we set the Rect in this same location. But then when we move our ship, when we move it left, right, up, or down, the Rect stays there. So we got to allow the ship to move with the Rect. So we move the Rect and the ship moves, or move the Rect with the ship, right? In our check to move, we have these move left, move right, that sort of stuff, right? So I'm coming down here. And if you notice, these functions are moving the image itself. And so there's no way for the Rect to be able to follow that. So we need a variable that does its own calculations, and wherever that calculation leads, something else can follow it. So we have to actually recode this right here. And so instead of this being like this, we're going to want to, we want to use that Rect. Okay, so we're going to use the Rect ship. And that's going to be the Rect ship X location here for the left, right? And it's going to be plus speed. So if you look what I'm doing here, right now I'm taking the left of the alien ship and I'm adding 1. So in this one, I'm taking the Rect portion of the ship dot X, and I'm going to add whatever, right? 1. But I think what I want is a variable called speed here. So if you look at this, I have this variable called speed all the way up at the top here. And I set it to 5. You can set it to whatever you want. And I'm just going to add that speed to whatever I'm using here. So instead of using this, I'm going to go ahead and change all of these to using the Rect. So let me pause that for a second. All right, so I have everything using the Rect. So when I go up here, I can see that it's checking the collision of the Rect. Now, the only thing I need to do now is be able to set my alien ship to the Rect's location. So instead of me moving the alien ship, I'm only moving the Rect and not the alien ship. And the way I'm going to do that is through the canvas again. Just like I was able to find where it was through the canvas, I'm also going to be able to set where it is through the canvas class. And if you don't do it that way, again, you're going to be running into a lot of issues here. So I think I'm going to do that in the check. Let's look for the check move. Right here. So after we check our movement, down here is where we want to go ahead and put that there. So I'm going to put canvas.set instead of get left. And I want to set the alien ship. And what do I want to set it as? I want to set it to the Rect ship. And I want to set that to the X. And then I want to also do the Y. And that's not going to be the left, it's going to be the top. Perfect. Now let's see if this works. Yes, it works. So see, when I went to the north, you notice down here we're getting all these hits, right? So now we can just go ahead and do the rest. Now this video is getting a little bit too long, so I'm going to stop it right here and we'll finish off in the next video. I'll see you guys next time. Make sure you subscribe and make sure you share this video, and I'll see you in the next video.